All right. Experimental and theoretical probability is student handout 2. We're learning what these two definitions actually mean. That's what the whole lesson's about. So experimental probability is the ratio of the number of times an event occurs to the total number of trials. This is like your what does happen. That's experimental. Theoretical probability is the probability of an event happening based on the possible outcomes. This is the what should happen. So I'm going to explain kind of a better definition than the true definition. Okay, so the difference between experimental and theoretical. What does experimental sound like? Experiment. Theoretical, what word can you get from that?
Theory.
Theory. Well, an experiment is where you're testing something, right? Theory, if I had a theory about Jose, what does that mean? If I have a theory that Jose copied his homework, then what am I using to base that theory off of? The fact that I saw him copy his homework. Okay? So a theory is based on something you know about the situation.
How did I copy my homework? I did it.
You told me you copied off of Adrian.
I said I copied my homework onto Adrian's paper.
Yes,
So you
and that's
still
what I'm
cheated.
upset about.
I wasn't here.
Anyways,
It's almost a good homework.
quiet. Yeah. So theory is what should happen with a dice, like this dice. How many sides does it have? 6. Okay. Theoretical, how many times would it land on a 3?
One
Out of 6
rolls.
1 out of 6 chances it could land on a 3. That's theoretical. That's what should happen. But if I sat here and rolled it 10 times, do you think that's exactly what's going to happen? Should it be close to that? Yes, that's not exactly what's going to happen, but that's going to be what's close to that. So, gamblers, that's an experiment. They're testing an experiment. They should know walking in whether they're playing cards or whether they are rolling dice or some sort of game. They should know the theoretical probability, the chances of something happening. It's going to be close to that. Is it going to happen every time? No, that's why they end up, some people win money. That's why lots of people lose money. They're testing the theory, and they don't think the theory is going to be right. Sometimes it is right, and you're not going to win. Sometimes it's wrong, and you win. But that's very rare because it stays close to the theoretical. So experimental is actually doing the experiment. Theoretical is based on facts you know. All right. So, moving on here. I don't need this guy right now. Says use a spinner below to answer the question. So we're going to answer theoretically what should happen with this spinner, and then we're going to test it experiment. So theoretically, what is the probability of spinning a section with stripes? Well, how many sections have a stripe? One. Out of how many total sections?
8.
8. So my theoretical probability is 1 over 8. Someone with the calculator, tell me what that is as a decimal. 1 divided by 8.
0.125.
0.125.
Okay, I'm going to use that later. Okay. B says, what is the theoretical probability of spinning a section with stars? How many sections have stars? 2. Out of how many?
8.
Can 2 over 8 simplify?
Yes.
2, 1/4. What is that as a decimal?
0.25.
0.25. C says, what is the theoretical probability of not spinning a solid or a stripe? So how many spaces is not a solid or a stripe? Okay, so I'm looking at the stars and dots, and that is 3 out of how many? 8. What is that as a decimal?
0.375.
375. Alright, so I looked theoretical. Now we're going to test it experimental. So you will be our spinner. You know how to work that? Alright, so you're spinning 10 times. And we're going to keep a tally of what she lands on. So when you land on something, let us know. Alright, have at it. Alright, she's preparing.
Stripes.
Stripes. So put a tally of stripes.
Stars.
Stars.
Blank.
Alright, so white.
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 Stripes.
Stripes.
White.
White.
Stars.
Stars.
White.
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 Hold on. Whoops.
One more.
Hold on. Let's count.
One more. One more spin.
So we have 5, 6, 7, 8, 9. One more spin.
Stripes.
Stripes. Oh, no dots. So what was the total number that we got on stripes? 3. White we got 5. Dots 0 and stars 2. So now we want to find the experimental probability. Well, how many times did we spin it? 10. So we landed on stripes 3 out of 10 times. What is that as a decimal? 0.3. All right. White, we landed on 5 out of 10. What is that as a decimal? 0.5. Dots, we landed on 0 out of 10. What is that?
0.
0. And stars, 2 out of 10. What is that as a decimal? 0.2. All right. Well, let's see how our experiment played out with the theoretical. So stripes. What was the theoretical probability of getting stripes? 1 out of what? 1 out of 8, which was 0.125. Was our experiment close to that?
Round it up. Wait.
It was off a little. It was kind of close, but it was kind of off actually. White. What was the probability of landing on a white? 1, 2, 3, 4 out of 8, which is what? 1/2, which is 50%. That's exactly right. Did our experiment matched our theoretical? Dots. How many times can I land on dot? 1 out of 8. And that gives me 0.0125. And we got 0. Is that close? Yeah, a little. Stars. We could land on 2 out of 8. What is that's 1/4, so 0.25, and we got 0.2. Am I close? I'm pretty close on that one. So, if you were gambling with all the money you have, would you stick and use your theoretical and test it with your gambling of the experiment?
No. Wait.
It's pretty close on all of them. I would. That's why I don't gamble, because chances are I'll probably would lose my money. It ain't good. It ain't good odds. So I look at the math of it all. If you know a really smart math person, either one, they're super smart and they can rig the casinos and they win, or they're super smart and they know the odds of winning is extremely low that they don't gamble.
The first one's being a Jose.
Rigging the casino? Good luck with that. The casino is the most secure area. They make sure everything is in their favor for you not to win.
But you see, Mexico is another.
Okay. All right, so we have a question to ask about this data. It says, are there any results in which the theoretical and experimental probability are the same? Why and why not? Did we find any that were the same?
Yes.
White was the same. Was anybody else?
No.
Everybody else was close. So we can say white had the same probability and everything else was close. All right, moving to the back, we are going to talk about relative frequency. Relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. As the number of trials increase, the relative frequency of an event will approach the theoretical probability. All right, so I'm going to explain what that exactly means. So if I have a dice, theoretically, what is the chances of landing on a 3? 1 out of 6 chances to land on a 3. That's the theoretical. Well, if I experimented that and rolled this 10 times, do you think I'm probably going to land on 3 1 out of 6 times? No, but it's going to be pretty close if I do. It's probably not going to happen. But if I rolled it 100 or 1,000 times, it's going to end up being close to dead on to my theoretical probability of 1 out of 6 times. So the more times you experiment, the closer your probability becomes to your theoretical. So if you rolled it just a few times, it's probably not going to be dead on. You roll it a lot of times, it's most likely going to be dead on. So if I play the lottery one time in 10 years, am I probably going to be a lottery winner? But if I play it every week for 10 years straight, does my chances get a little better? It's turning out to be more like my theoretical probability. I'm at least playing and seeing if I could hit the jackpot every time. But if I don't play at all, it's not going to be close to the theoretical probability. So, yesterday, I pulled someone and we spun this spunner 50 times. And I got the result shown here. Spunner? Spinner?
Shh.
Sorry.
We're trying to do it discreetly.
Okay. Yes.
I want to be the spinner.
So, it was already spun, so there is not a spinner, because I've already spun it 50 times. Alright, and so how many times did it land on a 1? And it landed on a 2, 8, 3, 13, and so forth. So I'm going to find my relative frequency. Well, how many times did it land on a 1? 12 out of how many total times?
50.
Can 12 out of 50 simplify? I can divide both by 2 and I get 6 out of 25. What is that as a decimal? Can someone tell me? 6 divided by 25? 0.24. Okay. Landing on a 2. I landed 8 times out of 50. Can 8 over 50 simplify? 4 over 25. What is 4 divided by 25? What? 0.16. All right. A 3, I landed on 13 out of 50 times. Can that simplify? No, 13's prime. So what is 13 over 50? Gives me 0.26. Then 10 over 50. Can that simplify?
Yes.
To
1 over 5.
1 over 5, and that gives me 0.2 or 20. And 7 over 50, 7's prime, so that's not going to simplify. 7 over 50, 7 divided by 50 gives me 0.14. All right, that was my relative frequency, or experimental. Theoretically, how many times could it land on a 2? 1 out of how many spots? 5. What is 1 out of 5 as a decimal? 0.2. So, did any of these match my theoretical probability?
4.
Yeah, 4 matched it. Was the rest of them close to a 0.20? Most of them was pretty close. I had a 0.24, 0.16, 0.26, 0.14. It was somewhat close. That was spinning 50 times. What happens if I spin it 100 times? What should happen?
gonna match.
It should end up getting closer to my theoretical of 0.20. So we're actually going to do that. But we're going to do it in an organized fashion, in a faster fashion here. I have my paper clip stuck there. Alright, so this first row here is going to be spinning. DeAndre is going to count how many times she calls out an answer. Right? Alright, so I'm going to keep a tally up here. She's going to spin, tell me an answer, 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 then it goes back to her. Everybody's calling out 10 times.
So I count when she says me or
Yeah. Well, count her. She can only speak 10 times.
So I'm supposed to speak.
She told you, right? 1.
All right. She spun and got a 1. Next.
5.
5. Next.
5.
5. Next.
4.
Next.
3.
Next.
5.
Next.
3.
Next.
1.
Next. Next.
5.
Next.
5. 1.
Next. 1.
2.
2.
2.
2.
5.
5.
1.
1.
1.
1.
5.
5.
4.
4.
5.
5.
1.
1.
5.
5.
2.
2.
1.
1.
5.
5.
1.
1. 1.
3.
3.
1.
1.
4.
4.
2.
2. 3.
3.
3.
3.
3.
1.
1.
4.
4. Pause. How many times you got her going?
Like 8.
Okay, so let's go 2 more and see what we're at. You're at 4. So 4,
2.
2, 1, 3,
2.
2.
Alright, that's it. 4. That's something else.
They keep going up 4,
5.
5,
3.
3,
4.
4. All right, I should have 50. 5, 10, 15, 20, 25, 30, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. So we need one more round.
5.
5,
4.
4,
1.
1, 1,
5.
and a 5. All right. So 1 got landed on 14 times. 2, 6. What is that? 9, 8, and 13. So I need to add that to my other 50 times that I spun. So 12 plus 14 gives me 26. 8 plus 6 gives me 14. 13 plus 9 gives me
22.
22. 10 plus 8 gives me 18. And 7 plus 13 gives me 20. All right. So now I'm looking at my new relative frequency. They should have become closer to 0.20. So I have 26 times out of 100. That gives me 0.26. Did they get closer or further away for that one? It got further away. That's why it's called probability. All right, then I had 14 out of 100. That is 0.14. Did that one get closer or further away? Wow, not working in our favor here. I got 22 out of 100. 0.22. Did that get closer or further away? That one got closer. 18 out of 100 gives me 0.18. Closer or further away? Further away. It was 0.20. And here we got 20 out of 100. That gives me 0.20. Did that one get closer or further away?
Closer.
Closer. It got dead on. So some of them got closer, some of them got further away. What patterns do you discover? For the most part, theoretically, the probability of landing on each number is 20%. After 100 spins, most of the experimental probabilities are at or close to 20%. Alright, we're going to ask some questions about the spinner down below. Says, what is the theoretical probability of spinning each of the numbers? Well, what was the theoretical probability of landing on a 1? 1 out of, how many spots were there? 5, which was 20%. Well, what's the theoretical of landing on a 2? 1 out of 5, 20%. What was it for landing on a 3? 1 out of 5, 20%. What was it on a 4? 1 out of 5, 20%. And a 5, 1 out of 5, 20%. They all had equal chances of being landed on. Not necessarily did they actually land on it equally, but they had an equal chance. How does the relative frequency change between when the spinner is spun 50 times versus the 100 times? You can write what they say, or you can write what I'm about to say. They said, as the number of trials increase, the more the long-term relative frequency approaches the theoretical probability. Or you could write, the more spins, the closer it becomes to theoretical. The more spins, the closer to theoretical. The more spins, the closer to theoretical. It's basically what that says. Six says, suppose the spinner is spun 1,000 times. Predict the relative frequency of each spin. So if you wanted to bet all your money of the probability of the spinner landing on a 1, would you go with the theoretical or make up a random one?
Theoretical.
I would probably, but I'm a math person, I would go with the math data, and because it's going to be close to that. And it's being spun 1,000 times. So chances are it's going to get pretty darn close to the theoretical. So what would you predict a 1 to be landed on? 20%? Or what is it as a fraction? 1/5. That's what I would predict. What would you predict it for a 2 being landed on? I would. That's what I would do. 1/5, 20%. I would probably do that for all of them. Do you think everybody who's betting would do that? Probably not. I like going with the data. All right, so you have the 10 minutes of homework time for homework 2 being checked tomorrow. Your Geo Packet 3 is due Friday. I had some people try and turn it in yesterday. Where did it go? It sure enough went into the trash.
That's sad.
Yep, sure is. Thanks for listening. Make good grades.
Yay.